So let's make sure you have the stuff you need before we do this lesson on area. Make sure you're in your lessons packet for measurement and modeling, the one with the pizza box, and find the lesson titled The Area of Polygons. This lesson is going to review some area information that I'm going to assume that you did learn in some past classes. To start out, let's talk about what area is, just a quick review of that. It is the measurement of the amount of space that's inside a two-dimensional object. Now, perimeter is the distance around the space. Now we're going inside the space. And your units are going to be square units. How many square inches, square feet, or square meters, that kind of thing, can you fit inside of the object? Exercise 1 here is just to illustrate, not because it's difficult, but to illustrate what we mean by that space filled with the square units. So if I took a ruler and just measured across this rectangle at 8 centimeters long and 5 centimeters down the side, we know just the definition of multiplication is that if I take those 8 and 5 centimeters on each dimension and multiply those, I'm going to get 40 of those little squares, literally squares, each one being a centimeter wide and a centimeter tall, and called a square centimeter. Let me try that again. 1 square centimeter, here's an abbreviation for it. We also use the abbreviation square centimeters like this. It's actually incorrect to call that centimeters squared because we want to identify the fact that it's an object, a thing that's the shape of a square and the number that we can fit inside there. So I'm going to assume, like I said, that you have seen area formulas before. We're just going to review 2 of them for this lesson. These 2 formulas, the first one for the area of a parallelogram, and it's given to be the base multiplied by the height. Now let me warn you about a common error that might occur to you here. When we talk about the base and the height, I want you to notice that the base is one of the sides of the parallelogram, and the height is measured to the opposite side. And what kind of an angle would that make? They've drawn it out here, but I'm going to put it inside right here. That is the height because it makes a right angle with the base. And for all of the area formulas we're going to use, that right angle is going to be really important. So I want you to write down here that the base is always going to be perpendicular to the height. So let's make a note of that for every area formula we do. That's also true of the triangle. A triangle is half of a parallelogram, so you see the 1/2 factor in there. But again, it's a base, and then the height measured from the opposite point, the vertex here, straight down to hit the base at a right angle. That's going to be crucial. Exercise 2 is kind of highlighting that. We have a patio that's going to be made in the shape of an isosceles triangle, and isosceles triangles are going to be one of the most important triangles we study with area. Why would the calculation taking A equals 1/2 of 22 times 16 not result in the correct area? So here's the calculation we're going to make, but this is wrong. What's wrong with it? Well, in the diagram, we have 16. You can think of that as the base. And we have the 22, which is one of the sides down to the base. The problem, I hope you can see, is that the angle right here is not 90 degrees. We need to have a 90-degree angle to make this work. So I'd like you to just make a note of that, that the 16 is the base, but the 22 is not perpendicular to the base. All right, so in part B, how are we going to figure out the area if we don't have the information we need? Well, we're just going to do the work to figure it out. All right, let's draw the actual height. Come from this vertex and go straight through until you hit the base at a right angle. There's a 90-degree angle. Now, what that creates is a right triangle. So we have some tools with our Pythagorean Theorem as well as SOHCAHTOA we'll be employing here. You might also remember that the symmetry of the isosceles triangle means that this 16 feet at the bottom can be split into 2 equal parts. So they would have 8 feet here and on the opposite side, 8 feet there. So it hits at the midpoint. Okay, so let's use the right triangle that we just created and let's figure out what the height is. Coming out, this is 8 feet, and down the side diagonally, we know it's 22 feet. And let's label this as the actual height. And let me put it in here too, in the picture. All right, and there's a right angle. Well, this is just 2 sides known and 1 side we want to figure out. So Pythagorean Theorem is our formula to use. We're going to go 8 squared plus the height squared. 22 is the hypotenuse. We'll put that by itself and square it. All right, running the numbers, 8 squared is 64, and 22, let me get my calculator. I think it's 484. I'm not positive. Let's check it out. 22 squared. Holy cow, I'm impressed with myself. 484. All right. Okay, so if we subtract away the 64, we can isolate h squared, and that is, this is not as easy for me. I think I'm looking at 420, not 440, 420. So h is going to be the square root of 420. And no decimals yet. We are not to the final answer. Let's just use that as our height. We'll let the calculator handle that decimal in just a little bit. So let's say height is the square root of 420. Okay, so the area, let's remember this is a rectangle. And the formula for the area of a it's not a rectangle, hello, it's a triangle. The area formula for a triangle is 1/2 the base length multiplied by the perpendicular height. And making substitutions for those, our base is the full length, 16 feet all the way across the bottom, with a height all the way up to the top of the square root of 420. Okay, now's the time to get that calculator and let's figure out the area. So 1/2 times 16 times the square root of 420. Hope that handled it. Yeah, okay. 163.951 ... keeps on going. They said to round to the nearest square foot. So that's the whole number. So we're going to call this 164, closest. Okay, so we're looking at 164 square feet of area in our triangle. Now a follow-up to that, this patio is going to be covered by some stone here in part C. The cost of that stone is $12.25 per square foot. What will be the total cost for covering the patio? We've seen these kind of problems before. Let's take the total area, 164 square feet, and we'll multiply it by the cost for each of the square feet. So, $12.25 per square foot. So the square feet we see here is going to cancel with the square feet unit there. That'll put my units in dollars. And as far as the calculation goes, let's just grab the calculator back here. 164 square feet times 12.25. $2,009 for the stone on the patio. All right. So let's go to the next example. In this next example, we're going to be using the coordinate grid, which is kind of nice. There's some built-in tools there. We got a lot of perpendicular help for us. Exercise 3, the parallelogram ABCD has vertices. Let's plot these as we read it. Vertex A is at 0, 6. B is at 9, 6. C is at 6, -2. Sure, we come down with that. And they don't tell us where D is. That's our first question. So let's go ahead and draw in the segments for the parallelogram we do know. AB goes horizontally across the top. B is on a diagonal, slide down to C. Now point D is the rest of this. We know it's going to be over here somewhere. Let's just remember that it is a parallelogram. And what do we know about the opposite sides of a parallelogram? Well, we know they're congruent. So the top of this parallelogram, AB here, that's an easy count. Let's go ahead and count how far it is from A to B. I'm getting 9 units across. Let me label that. So it should be 9 units along the bottom. Let me just start from C and back count 9 units, and that should locate point D. 7, 8, 9. So point D is going to be right here. And let's read its coordinates. That's X value is -3 and Y value is -2. So D is -3, -2. Go ahead and finish filling in your parallelogram. Give everybody a second to catch up with me. As you do, I think you're going to probably want to know that this is 9 across the bottom, so go ahead and write in the 9 there for DC. All right, and you can pause the video if you need to catch up here. I'm going to go on to part B. We're going to determine the area of the parallelogram ABCD. So all parallelogram areas require a base number and a perpendicular height number to help us. So I'm going to choose the base to be the 9 units I see right here. And then I'm going to multiply by the height. Now I'm not going to measure my height diagonally or on any kind of slant. It has to be the height from the base straight up perpendicular to the opposite side. And you've got a lot of places to count that. I'm going to think of it right here, where it hits at a right angle, and just count straight up to the opposite side. 1, 2, 3, 4, 5, 6, 7, 8 units. That's the height of this parallelogram. So bringing that into our formula, 9 times 8 now is 72 square. Now we don't have any units given here, so I'm going to just indicate that this way, square units. That's our area. All right, another question following up on part C. Which is the longer side? Segment AB, right here at the top, we know that's 9. Or segment BC, and BC is our slanted side down this way. So let's make a note that AB we know is 9. What we don't know is BC's height. And BC is a slanted one. Well, we know right triangles can help us a lot. So let me just draw a little right triangle straight down from B to the level of C. Now we know that's 8. We counted that before. And then straight over, and that count right there is 3. So let's run the Pythagorean Theorem with 8 and 3 as our legs. There's a right angle, and we'll get BC right here. All right, so 8 squared plus 3 squared is equal to BC length squared. Square the 8, you get a 64. Add that to 9 for 3 times 3, and that's BC squared. Maybe I should have called it X. Okay, so adding those together is 73. That's the length of BC squared. Come up here with some space. We're not done until we have BC, so that's going to mean I'm going to square root the 73. And that's the distance from B to C. Let's get a sense of how big 73's square root it is. I'll take the square root of 73, about 8.5 if we're rounding it. Okay, so BC is only about 8.5 units. Clearly, the longer side is the 9-unit side. And so they wanted us to support our answer. Even if you visually could tell that that was a little bit longer, this is the evidence. So we're going to say BC is the longest, or the longer side. Okay, now in our final example, we are going to see some trigonometry. We can't let SOHCAHTOA not have a chance here. Another isosceles triangle. This isosceles triangle has an angle at the vertex that is a 46-degree angle. This process you're going to see is going to be important in our next lesson when we start talking about it with circles and how circle areas are determined. So let's walk through the steps. Part A, they ask us to find an expression involving a trig ratio for the height of the triangle and leave it unevaluated. So we're not going to put it into any decimal form. But let me remind you, the height of the triangle is from the vertex point straight down to hit the base at a right angle. And the symmetry of this, if you think about it as you draw it, what did you just do to the 46-degree angle as you drew that? Well, we just cut it in half. We bisected that angle to make 2 smaller angles, each half of 46. So let's figure out what each of those are. 46 and divided by 2 is only 23 degrees in each of these angles. Let me shade one in. It's a 23-degree angle. We also cut the side down here at the base in half as well. So let me call this X, and that's only half of the full length across. Keep that in mind for the next couple of steps. Now, what we have is a right triangle. I like to sketch it again here. The 10-inch side is the slanted hypotenuse. 23 is the angle of perspective here at the top. And I'd like to figure out the height of the triangle. I'll call it h. Now h here stands for height. Don't confuse that with hypotenuse. We are going to need to use a cosine ratio to figure out the height, since the height is adjacent and the 10 is the hypotenuse. So using the cosine ratio, using the 23-degree angle of perspective, looks like the height would be divided by the 10 to equal our cosine of 23. Putting this over 1 so we can see an easy cross multiply. 1 times the h is h, and that's going to be equivalent to 10 multiplied by the cosine of 23. They want us to leave it unevaluated, so this is the way I'm going to leave my answer. In fact, I'll box it. That's the height measurement for our triangle. I'm also going to come over here and put it in the picture. This is 10 cosine of 23 degrees. Okay. Part B, let's see what we need to do. We're going to find an expression involving a trig ratio for the length of the base of the triangle. We're also going to leave this unevaluated. So the base of the triangle is the whole length here. This is what we have to figure out. We will not be able to figure out the whole thing until we figure out with the right triangle this x length. So let's use the same diagram here, but bring down the length x. And in our work, let's show how we can figure out this x side. Still using the 23-degree angle and the 10 hypotenuse, what ratio would you use to figure out x? Think about that. If you need the opposite side and you have the hypotenuse, you should be saying the sine ratio. So it's the sine of the 23-degree angle equal to the fraction, the ratio x over 10. Just like above, we're going to put this over 1. 1 times x in the cross multiply is equal to 10 times the sine of 23. And leave that unevaluated, so don't be reaching for your calculator. Now, this is just this part of the side we need. This is 10 sine of 23. We need to know the full length of the base. So let's multiply that by 2. And let me show how I'm going to do this. The base is equal to 2 multiplied by 10 times the sine of 23, or 20 sine of 23 degrees. That's the length of the full base of the triangle. Okay, we wrap up this problem with the question of area. Determine the area of the isosceles triangle to the nearest square inch. This one we'll put in our calculator. Bringing in all the information we just figured out, let's start with the formula of a triangle area. Triangle area is half the base times the height. So that 1/2 factor is going to be part of our formula. We'll put the base value in, that we got as 20 sine of 23, and bring in the height that we got, and that was 10 cosine of 23 from part A. Now I'm wishing I would have been better at my color coding here. I'm going to make this one blue. All right. So you can put that into your calculator. If you want to do a little bit of simplifying before it goes in the calculator, that is also an option. For example, we can take half of 20 if we'd like to. We can call half of 20 10 with the sine of 23 times 10 times the cosine of 23. And you can multiply the 10s together. So you can call that 10 times 10, or 100, times the sine of 23 times the cosine of 23. All of these will give you the same answer. Eventually, it's all going to go into calculator. So I'm going to show both ways. If I left it unsimplified, it's just more typing and parentheses to deal with. Let me clear this out. So I'm going to have to put in my 1/2 and then multiply, hit times, by the sine of 23. Close that parenthesis. Multiply by 10 times the cosine of 23. Close that parenthesis. Okay, so we're looking at, to the nearest square inch, 36 square inches. Now, it's a little bit easier because I did some simplifying work. If I do my simplified version into the calculator, just 100 sine 23 cosine 23, I get the same answer. So you make sure you know how to appropriately put that in the calculator. I know the parentheses can be tricky sometimes. Please take the minute and do this on your own in the calculator. Make sure you know how to do it. Our final answer on this one is approximately 36 square inches. 36 little squares, each an inch in dimension. Okay, so tackle the homework. Go to your homework packet, look for those C problems, do those first, then level up to the B problems, and finally level up to the A problems, and that'll get you an A grade. All right, I'll see you in class.